Right then, in our next look at the basics of OpenMP, we're going to start to look at using some of the OMP functions, some of the runtime functions that we can use in order to support OpenMP. And specifically what we're going to look at here is how do we count threads? How do we see the number of threads that are available to us? So here is our standard program. We start off, we go in, we form a parallel region, we print hello world, we come back and print goodbye world. Let's just compile this. Just to remind us of what comes out. And we can see that we get the 10, because we have 10 processes in this machine, 10 hello worlds, and then a goodbye world. We're branching into a parallel region here. We then rejoin here and then go through on a single thread to print goodbye world. So let's see if we can add some things, some data in here. So if we said hello world from thread, %d of %d. So we're wanting to put two numeric variables in, from thread, the number of the thread, and then the total number of threads. And you can see actually, look, VS Code very helpfully has suggested our features. So it suggests for the first one, thread number, is OMP get thread num. And the next method is OMP get num threads, the total. So that's absolutely right. I think if I hit tab, it accepts it. And no, I want to get rid of that. Let's just space this out a little bit, just for neatness. So you can see hello world from thread OMP get thread num of OMP get num threads. So save that, recompile it, and let's run it. And here we are. So we can see now hello world from thread 8 of 10, 6 of 10, so on and so forth. Now, one thing that is worth pointing out is, again, as we mentioned previously, the number of total threads by default is the number of cores or the number of processes available. Processes in OMP speak is what we would call cores, the number of sort of threads of execution available. They're numbered from 0 up, as with any self-respecting kind of computer science numbering system, but we don't guarantee the order in which we get them. So you can see that thread 8 executes first, then 6, 5, 1, 2, 0, 3, 9, 7, 4. 0 is the main thread, the master thread in OMP parlance that's been running through, but you can then see that the other threads execute in whatever order. Now let's have a look at some more options that we can put in. So let's at the top here start using some other OpenMP functions. So let's have a look. So let's printf here the maximum number of threads. See if Visual Studio, yep, OMP get max threads. So this is a call that tells us how many is the potential maximum number of threads that the system can use in terms of a team. And then the next line we're going to use is printf number of processes. So in OpenMP speak, processes are cores. It's just the thing, the count, to see how many processes are available, how many threads can be executed. Now, this terminology goes back to the idea that in the early days of this technology, all processes were single-threaded, and the way that you accomplished multi-threading, multi-processing was you had literally multiple sockets with processors in. Nowadays, in this machine I'm using here, there is one socket, there is one processor, but it has 10 cores within it. So it will come up hopefully as 10 maximum number of processors. So let's have a look and just run that, see what this says. Okay, and you can see maximum threads 10, number of processors 10. So it's identified the number of processors within our MacBook, and it's saying that the maximum threads available are 10. And what that means is it's not the maximum number of threads that we can spawn should we wish to, it's the maximum number of threads that OpenMP will spawn or form in a team by default. It might do less than that if it detects that it doesn't need to be the full amount, but that's the maximum amount that it will do. We can, however, influence that. So if we just copy this here, go down, and what I'm going to do is I'm going to do OMP set num threads, and let's set it to 50. So at this point, what we're asking is we're saying to OpenMP, I want you to set the number of threads or the maximum number of threads to 50. When we now compile and run this code, we notice two things. Obviously, this is being executed, our threaded code, our parallel region is being executed 50 times. So in our first iteration, before we set anything, you can see maximum threads 10, number of processors 10. After we've set the number of threads to 50, maximum threads becomes 50, number of processors becomes 10. Now it's worth just sort of pausing and thinking about this for a second. I have 10 cores within this machine. Does that mean really that I have a maximum of 10 threads? Well, no, as you can see, I'm able to set it to any number that I want. My machine is being used by all sorts of processes. I mean, at this point, it's recording a video, it's running VS Code, which no doubt has all sorts of threads running in the background. So there's a lot of things going on, and I can set the number of threads as I wish. There are, when we get into the more technical details of OpenMP, advantages and disadvantages to higher numbers of threads. If we have, for example, a situation where the threads are going to spend a lot of time waiting, so they're waiting for I/O or something like that, then it makes sense to have a higher number of threads than there are processors available. If the threads are purely computational, i.e. when they're running, they are running 100% of the capacity, well then, whether we specify 10 or whether we specify 50, there only are so many CPU cycles, and we might actually start to slow things down if we go much higher than that. So there we go, rudimentary introduction to how we can test the number of threads, how we can see the number of threads, and how we can change them.